Good morning, everyone. Thank you for joining us. As we were preparing for this event, we were all devastated by the news coming out of Las Vegas, as I'm sure all of you were. And that's coming off a challenging past few weeks with Hurricanes Harvey, Irma, and Maria, and other events around the world. It's been hard to see the suffering, but I've been moved and inspired by everyday heroism. People opening up their homes, and to first responders literally risking their lives to save other people. Our hearts and prayers are with the victims and families impacted by these terrible events. We are working closely with many relief agencies in affected areas, and we are committed to doing our part. It's a true privilege to be at the SF Jazz Center. It's a great American institution for jazz performance and education. And it's really good to see familiar faces in the audience. As always, I want to give a shout out to people joining us on the live stream globally from around the world. Since last year and since Google I/O, we've been working hard, continuing our shift from a mobile-first to an AI-first world. We are rethinking all our core products and working hard to solve user problems by applying machine learning and AI. Let me give you an example. Recently, I visited Lagos in Nigeria. It's a city of 21 million people. It's an incredibly dynamic, vibrant, and ever-growing city. Many people are coming online for the first time. So it's very exciting, unless you happen to be in the Google Maps team and you have to map the city. And it is changing so fast. And normally, we map a place by using Street View and doing a lot of stuff automatically. But it's difficult to do that in a place like Lagos because the city is changing. You can't always see the signage clearly. And there are variable address conventions. Things are insequential. So for example, take that house there. If you squint hard, you can see the street number there. It is number 3 to the left of the gate. That was relatively easy. On to a harder problem now. That house, that's what we see from Street View. I think as humans, it's probably pretty hard. Maybe one or two of you can spot it out. But our computer vision systems, thanks to machine learning, can pick it out, identify the street number, and start mapping the house. So we approached Lagos completely differently. We deployed machine learning from the ground up. And just in 5 months, the team was able to map 5,000 kilometers of new roads, 50,000 new addresses, and 100,000 businesses. And it's something which makes a real difference for millions of users there, as Google Maps is popular. And we think this approach is broadly applicable. Let's come closer to home. Parking in San Francisco. I don't even try it anymore, but for those of you who try it, we again use machine learning. We understand location data. We try to understand patterns, our cars circling around. And the color shows the density of parking. And we can analyze it throughout the day and predict parking difficulty. And in Google Maps, give you options. A simple example, but it's the kind of everyday use case for which we are using machine learning to make a difference. The best example I can think of, what we've talked before, is Google Translation. I literally remember many years ago adding translation in Chrome and making it automatic so that if you land in a page different from your language, we do that for you. Fast forward to today, with the power of machine learning and our neural machine translation, we serve over 2 billion translations in many, many languages every single day. To me, shows the power of staying at a problem, constantly using computer science to make it better, and seeing users respond to it at scale. This is why we are excited about the shift from a mobile-first to an AI-first world. It is not just about applying machine learning in our products, but it's radically rethinking how computing should work. At a higher level, in an AI-first world, I believe computers should adapt to how people live their lives, rather than people having to adapt to computers. And so we think about 4 core attributes as part of this experience. First, People should be able to interact with computing in a natural and seamless way. Mobile took us a step in this direction with multi-touch, but increasingly, it needs to be conversational, sensory. We need to be able to use our voice, gestures, and vision to make the experience much more seamless. Second, it is going to be ambient. Computing is going to evolve beyond the phone, be there in many screens, around you when you need it, working for you. Third, we think it needs to be thoughtfully contextual. Mobile gave us limited context. With identity, your location, we were able to improve the experience significantly. In an AI-first world, we can have a lot more context and apply it thoughtfully. For example, if you're into fitness and you land in a new city, we can suggest running routes, maybe gyms nearby, and healthy eating options. And in my case, being a vegetarian and having a weakness for desserts, maybe suggest the right restaurants for me. Finally, and probably the most important of it all, computing needs to learn and adapt constantly over time. It just doesn't work that way today. In mobile, developers write software and constantly ship updates. But let me give a small example. I use Google Calendar all the time. On Sundays, I try to get a weekly view of how my week looks like. But once the work week starts, say on a Monday or a Tuesday, I'm trying to get a view into what the next few hours looks like. I have to constantly toggle back and forth. Google Calendar should automatically understand my context and show me the right view. It's a very simple example, but software needs to fundamentally change how it works. It needs to learn and adapt. And that applies to important things like security and privacy as well. Today, a lot of us deal with security and privacy by putting the onus back on users. We give them many settings and toggles to improve those. But in an AI-first world, we can learn and adapt and do it thoughtfully for our users. For example, if it's a notification for your doctor's appointment, we need to treat it sensitively and differently than just telling you when you need to start driving to work. So we're really excited by this shift, and that's why we are here today. We've been working on software and hardware together because that's the best way to drive the shifts in computing forward. But we think we are at a unique moment in time where we can bring a combination of AI and software and hardware to bring a different perspective to solving problems for users. And we are very confident about our approach here because we are at the forefront of driving the shifts with AI. 3 months ago at Google I/O, our Google AI teams announced a new approach called AutoML. AutoML is just our machines automatically generating machine learning models. Today, these are handcrafted by machine learning scientists. And literally, only a few thousands of scientists around the world can do this. Design the number of layers, weight and connect the neurons appropriately. It's very hard to do. We want to democratize this. We want to bring this to more people. We want to enable hundreds of thousands of developers to be able to do it. So we've been working on this technology called AutoML. And just in the past month, for a standard task like image classification, understanding images, our AutoML models are now not only more accurate than the best human-generated models, but they are more resource efficient. So it's pretty amazing to see. We are now taking it a step further. Let me talk about another use case, object detection. When we say object detection, just a fancy name for computers trying to delineate and understand images, being able to draw bounding boxes and distinguish between all the vehicles there, scooters, mopeds, motorcycles, and even pick out the bike in front. It has a lot of practical use cases. The Street View example for Legos works based on object detection. Google Lens, which you'll hear about later, as well as our photography in Pixel, uses object detection. This is really hard to do. The best human-generated models we have only have a 39% accuracy. But our AutoML models, as of the past couple of weeks, have reached around 43% accuracy. They're constantly getting better. So the rate at which we are seeing progress with AI is amazing, which is why we are really excited about combining it with our software and hardware to bring it together for our users. Let me give you a concrete example. I was recently very inspired by this tweet from a journalist who was attending the Little League World Series. As you can see, there are two Little Leaguers here, one from Dominican Republic and the other from South Dakota, and they're talking to each other using Google Translate. It's a great example, but I looked at it and I feel like we could do a whole lot better. Computing needs to evolve where this happens in a more natural, seamless, and a conversational way. And later today, you'll get an early glimpse of how we can push this experience further by thinking about AI software and hardware together. I couldn't be more excited by the direction our hardware team is taking and approaching their work here. So to give you a lot more insights, let me welcome Rick onto the stage. Thank you.